ABC is a triangle with M and P the midpoint of three sides. X is a fixed point inside the smaller triangle. Three lines passing X will be constructed. The first line intersects AB and AC at C1 and C2 respectively. The second line intersects BC and AB at points A1 and C2 respectively. The third line passing BC and CA at point B1 and A2 respectively. Question: how do we position the lines so that the sum of three triangles XA1A2, XB1B2, and XC1C2 is minimized? This is a question asked by a viewer of my channel. His name is Alexander. Let's look at a GeoGebra demonstration. We are going to adjust one line and keep the other two lines unchanged. This way, the triangle XA1A2 is unchanged, and our objective is to minimize the other two triangles. However, these two triangles, if combined with a fixed quadrilateral, would form a single triangle AC1B2. The quadrilateral is fixed. Therefore, the objective is to adjust the line so that the triangle AC1B2 is as small as possible. The good news is that this is completely independent of the positions of the other two lines. So, the job is partitioned into three similar parts. First, adjusting the first line so that triangle AC1B2 has the smallest area. Second, adjusting the second line so that the triangle BC2A1 is as small as possible. And finally, adjusting the third line to come up with a small triangle CA2B1. These three triangles completely cover the triangle ABC with three overlapped areas. They are exactly our target triangles. Given an angle O and a fixed point X in it, how do we find a line passing X and the triangle OAB has the smallest area? Here's the answer. We want to choose the position of the line so that X is the midpoint of the segment AB. Let's draw another line through X So this new line has two intersections with the angles the D and the E. We want to prove triangle ODE has a larger area than triangle OAB. In other words, XAD has a larger area than XBE. This is easy to prove. We draw a parallel line from A and parallel to OB, and the intersection with the second line as a point F. It's very easy to see triangle XAF and the triangle XEB are congruent because X is the midpoint of AB and the parallel lines. And the triangle ADF is the actual area of the triangle ADX. The proof is done. The last part of the video is the actual construction of the lines. From one node, connecting X and extend it to another point to form a segment so that X is the midpoint of the segment. And from the new point, introducing two parallel lines parallel to the two sides of the nodes. This way, we construct a parallelogram, and the other diagonal is the line we want to construct. Finally, you might wonder why the point X must be kept inside the triangle MNP. Let's move it around, see what happened. When X is close to the boundary, look at the node on BC. It's approaching to C, and when it crosses over the boundary, the intersection out of the segment, out of the range. This is similar to the other side. For example, cross over to MP, the intersection on AB will be out of the range. So, the purpose of keep X inside the triangle is to guarantee the existence of the lines. Thank you for watching.